And welcome to Geometric Transformations. And as we continue with our geometry units, the first thing in this unit we're going to talk about is introducing to you the different types of transformations. And you may actually be familiar with these from when you were in algebra and we were doing transformations of functions. So some of this stuff may have a connection to that. But some of the, let's see here, what we want to do is we want to determine if a transformation is isometric and identify corresponding parts of a preimage and image, and then identify the types of transformation given a preimage and an image. So what is the preimage? The preimage is going to be where we start, and then the image is going to be where we end up. Isometry, well, that's a fancy word for a rigid transformation, and then a rigid that preserves the size or length, shape, lines, and angle measures of a figure, right? And then a rigid transformation is a transformation that, guess what? Preserves the size, the length, the shape, lines, and angle of a measure. So isometry is a rigid transformation. And then a transformation is simply a one-to-one mapping of all points of a figure to another figure. And we'll do a quick example. And in doing that, if you look at this figure, let me draw it, and we can see here that it looks like I have what would be a trapezoid. I have a 90-degree angle here, a 90-degree angle here. And then if I have another image of a trapezoid, and this trapezoid also, not a very pretty trapezoid, but has a 90-degree angle. Okay, so I have this other image, and it looks like they both have those 90-degree angles. And so if I start identifying some measurements, and what we have here is corresponding angles. That's one of the things I want to talk about, that when I do a comparison, let's see, I should probably do some labeling here. So we're going to go with A, B, C, D. So those are going to be my points, E, F, G, and H. And now when looking at this, it looks like initially we have segment AC could correspond with segment EG just by angles, but that's not quite right because we don't know about the length of it. But if I have a corresponding side, we'll call this side and this side. If those are congruent, then that makes them corresponding sides. And if I have another side here where I have AB, the length of AB and the length of EF are congruent, because that's what our marks indicate congruency. So it looks like AB is also a corresponding side to EF. And if I continue identifying these things, looks like FH is congruent to BD, and GH is congruent to CD. So I'm starting to I have congruent sides from one image to a next. And then if I have an angle here, which is going to be congruent to this angle of another figure. So it's corresponding angle from one figure to the other. And then I have this angle is congruent to this angle. So that makes that a corresponding angle. So corresponding sides are a pair of sides that have the same relative position in two congruent figures. So if we can see that these look like these are now congruent figures because of my congruent markings, we've indicated that they are identical. So congruent side AC is congruent to EG, AB is congruent to EF, BD is congruent to FH corresponding, and CD is corresponding to GH, because we have a congruent figure and corresponding sides. And of course, our corresponding angles are when we have a pair of angles that have the same relative position. So here again, it looks like angle here, this angle, which would be maybe ABD, is corresponding to angle EFH. So those are corresponding in how they work. These marks again indicate corresponding angles, and these tick marks indicate corresponding sides. And as we have these transformations, a transformation is a one-to-one mapping of all points of one figure to another. So in this figure, if I have ABC, and then I have a second figure, and this figure, when the transformation, so I have created a transformation, and hopefully you can see that these two figures are identical in shape and size as I have a slide. So I have transformed my first image to a new location, and we'll call this, for simple, DEF. My transformation, my map, A maps to E, and that would be my point A of the pre-image was mapped to point E of the new image. So again, this is my pre-image, that's my starting point, and then I mapped everything to my new image. And of course, hopefully you can see that B then maps to D, and C maps to F in the slide. That it's a transformation. There are different types of transformations, and rigid transformation is one where it preserves the size, the length, the shape, the lines, the angles. It's a identical image, just has been possibly reflected, moved, or rotated. And so a reflection may occur over a given point. So, for example, if we have this imaginary line, and then I were to have a reflection of that image, and we have flipped over and we have reflected over the imaginary line. It's not a very good line, is it? The imaginary line, L, and my image has just a mirror image, a reflection. Now, a translation, on the other hand, is when we may have, it has moved up, down, left, or right, but its orientation has changed. In this case, so I have the original image, and then my new image is a rigid transformation. It's a slide. I've moved it around, but the orientation hasn't changed. What appears to be up, as my image, like this is, if this was my top point of my image hasn't moved. So it has just, again, it is just call it a slide in some cases. That's what you'll hear it referred to as. So as I slide here, my orientation hasn't changed. Where when you look over here, my orientation was a flip. My orientation, because these 2 points are the mappings. And then if I come over here and I look at this rotation, now a rotation on the other hand is going to not slide, not reflect, but it is going to rotate on an axis. So I'm able to, this image, and it may rotate around an axis, or in this case, so here you can see that my new image has not only had a translation, but it has rotated on its axis a little bit. So that would be a rotation, that it has just moved along a rotational, let's see here, so here's our corresponding sides, and we can see that it has sort of turned this way a little bit to have its new orientation. And then finally, as we talk about non-rigid transformations, so as we deal with non-rigid transformations, we have a dilation and a stretch. Now, dilation is going to be a proportional enlargement or reduction. So in the proportional enlargement or reduction, what you're going to have is you're going to have corresponding angles. So my corresponding angles would remain what ties my transformation together. But as an enlargement, for example, if my different links, if I have A, B, C, D, and it is a dilation of E, F, G, H, what you'll see is a proportion. So if AC is 2, EF may be 6. Well, that is a 3 times enlargement. So if AB is going to be 4, EF then would correspondingly proportionally increase to 12. So of course the dilation is a proportion, and it can be identified. Again, when a dilation, you do have corresponding angles from the image and pre-image. Whereas a stretch may be a triangle, and we'll just use that as an example. And I have my side length of 2, and then I may have a same triangle, original side length of 2, they're corresponding, but maybe my sides have changed where it has been pulled out. So these angles have changed, but of course I do have this one side that is still maintained as they sort of pulled this point of it out. As they pulled the point of it out, we have a different stretch of the shape of my triangle, or maybe a rectangle or a trapezoid, and where we have this general shape. And of course we do have my angle markings. I do have some corresponding angles in a trapezoid, but maybe the next image, as we stretch it out, it's been stretched, we see this, that here's my corresponding angles, and one side has remained the same, where I have it, maybe this is 4, this is 4, 4, but where it used to be 6 wide, it is now 8 wide, and only 2 of the sides changed. So we have basically pulled it and stretched it out. The object has been stretched this way. This object was stretched that way. Where, if you remember in the dilation over here, it is stretched equally in all directions. It is just an enlargement. So those are the different types of transformations that we've been dealing with. And one last thing to add when we were talking about transformations will be our prime notation. And what this is used to indicate that a figure has undergone a transformation. So in this case, this image is from earlier in the slide, where maybe we have A, B, C, and D. So as we have this, new figure, we're going to have A prime, B prime, C prime, and D prime. And so that would be, for example, A, B, C, D, and then would be it maps to A prime, B prime, C prime, and D prime. And what we're showing there is this is my new image, this is my pre-image, and the arrow indicates the map, that the transformation maps to a figure onto its image. So that error is indicating that mapping. And those are just the notations. So when you see this prime indication here, you'll know that that is your mapping, or your transformation has occurred.